Hello, here is a simulation that will help teachers to experiment and the students can understand better. This shows the simulation of refraction. Here, this is a torch which sends a ray of light. Now, if I click the button here, the ray is emitted, and when I click once again, the ray de-emits. Now here the arrows indicate the position of the ray, at what angle it can be sent. Now this is the normal. As such, for refraction, you have two media. On the top, the white one is a rarer medium. You see here it is air. And the bottom, the colored one, is a denser medium where it is set to the limit for glass. The refractive index being 1.49, the refractive index of air being 1. Now here on the left hand side you see a toolbox where there is a protractor using which one can measure the angle of incidence or the angle of refraction. The protractor is so designed, and there is another which measures the intensity of the ray. After refraction, whether the intensity is the same, remains the same, or it will be different. Let us see this experiment. Now, I will emit a ray of light, which, since it passes from the rarer medium to the denser medium, that is from air to glass, it bends towards the normal, you see, in such a way that a part of the light will be reflected. As such, if we measure the angle of incidence, see it is coming to something like 30, 40, 46, yeah, something like that. And the angle of refraction is this, is 30. So keeping the angle of incidence differently, the students can be asked to measure the angle of incidence and the angle of refraction and calculate the refractive index for air to glass using the formula sin I by sin R is the refractive index. Now, once more, let us see what is the intensity. The intensity meter here, the ray for the incident ray, it is 100%. Whereas for the refracted ray, it is 90%, 90.37. And the rest is reflected. Okay, so that the total is 100%. Now, coming back, you can change this from water to glass also, as such. So in this case, the angle of refraction, incidence, and the angle of refraction varies as such. Now let us do it the other way. One more thing I forgot. It can also be sent as a wave. Yeah. But let us do with the ray only. Now we will find the total internal reflection. We'll make use of this as the ray going from the denser medium to the rarer medium. Okay. Now, this is the angle of incidence. You see, when the ray goes from the denser medium to the rarer medium, it goes away from the normal, and the angle of refraction is more than the angle of incidence. Now, what happens when the angle of incidence is gradually increased? A time will come when it grazes just to the surface of separation between the two. That angle, it is, you see, that angle which is for which the refracted ray grazes the surface between the two is known as the critical angle. Is known as the critical angle. Now it is difficult to use this to measure the critical angle because it is not so sophisticatedly made. So when the moment it comes out of the, if the angle of incidence is more than the critical angle, it gets reflected. Now let us see the intensity. Okay, the intensity is here 100% for the incident ray, and for the reflected ray also is 100%. So the ray is, instead of going into the other medium, it gets reflected back once the angle of incidence is more than the critical angle. Now this is the experiment with this for the different keeping the media different, the students can be asked to calculate differently. This is one of the best simulations which I ever um, uh, have seen. Now, incidentally, the same simulation also has the prism break, where the ray goes, and here you see there are number of prisms, so that one can find out what happens to the ray when it is going like this. And here, if it is a triangular prism, you can also, yeah, see the refraction. Now here there is one, this is uh, here the environment is air to glass. So here, which color you want, suppose say you want for the blue light, the angle of the refracted ray are is different altogether. Okay, now for the same incident ray, as the angle changes, see, it is slightly varying, although it is. Now you can also show multiple rays. You can also see reflections if there is any inside. See, this is you can also have a normal also at the point of incidence and refraction, and you can also use a protractor to measure it. So it works like this. Now this is one of the best simulations that can be offered to the teacher as well as the students. Thank you.